Hello, this is Kevin Singh with Deep Future Analytics, and thank you for joining us today for our software demonstration. For those of you unfamiliar with Deep Future Analytics, we are a QSO, 50% owned by New Vision Credit Union, 50% by Prescient Models. We took our credit union knowledge and combined it with the best loan modeling firm in the industry, and together we created a best-in-class system providing actionable and impactful solutions for financial institutions. We even caught the attention of one of the big four core providers, Jack Henry & Associates, who has chosen us to use as the engine to their CECL solutions for their ProfitStars clients. At Deep Future, we exist to help financial institutions reinvent lending. The way we do that is by arming decision makers with accurate and actionable information. How we do it is with our best-in-class software solution that's supported by a team of industry experts. Today, one of those industry experts is going to take you through the demonstration of that software. So I'd like to introduce you to Dr. Joseph Breeden, Deep Future CEO and head of the team that developed their software. I'm a little biased, but Joe is arguably the best-known name in the credit risk modeling industry. He literally wrote the book on loan modeling for our industry, as well as over 50 other trade publications in his name. His talents have been called upon across the world as he's created numerous financial models during numerous economic crises. Back home, he's been quoted numerous times by the ABA, FASB, and a number of other leading publications. And in fact, he's invented vintage modeling, which is FASB's recommended methodology for CECL. And now I'm going to turn it over to Joe.
Hello, this is Joe Breeden, and I'm going to take you through a demo of our software today and review some of the outputs that we get from the software and some of the capabilities that it has. Starting off, the example here is from one of our partners, formerly Denali Federal Credit Union, now New Vision Credit Union. So in the software, we start with a home page, and the home page is actually very configurable, and it's just a set of outputs that you might like to see each time you log in. You'll notice in the status bar, it shows the data range for the analysis, when the last models were run, software versions, things like that. And we can do a few things. Let's zoom in on one of these graphs. You can see here by vintage, this is a 12-month loss forecast, just a summary output. And you can see that this example is largely auto and credit card. If I flip this over, every graph, you can see the data behind it. Everything is exportable in our system. So if you want to export these numbers, you can do that at any time. We feel strongly about integrating with your other systems. We don't try to have everything in one place. I think that's impossible in today's world. So any graph you see, any table you see, or even the individual account level monthly forecast you can export, and we'll show you where all that is. Here on this 12-month forecast, obviously this is by vintage and product, just a standard report. We're looking at the next 12 months, and the number here for the loss forecast is 11.1 million. I want to remember that number for later. Everything in our system is scenario driven. You decide the scenarios. For this demo, I'm running two, one base and one severe. So I could flip this over and show you the severe scenario, but we'll have other chances to do that, so I'm going to keep going. We also, most of the tabs, you'll see a change dimensions button, and that lets you change the segmentation. For this initial view, I didn't have any segmentation, but what if I wanted to see it by state, because I'm in a couple of different states? Or if I wanted to see it by maybe channel is in here, the source of the loans. So I can do that split, and of course each product is independent, so I can split them however I like. I'm going to continue then. Let's look at scenarios. So the philosophy of our software is that we're not trying to deliver a modeling tool. There are lots of modeling tools, and most organizations, your analysts are overworked, or you may not have a PhD analyst who can go out and build your own models, or time to learn how to build the models in somebody's tool. So basically we have a team of PhDs, And as part of our installation process, we build the models for you. So to run the software, the job of your analyst is to manage the scenarios. So to decide what set of economic scenarios do we want to think about. If there is, for example, a severe recession, what kind of origination scenario would we have in response? Maybe we would cut back on new originations. So those are the kinds of considerations that we need to go into. Now, as far as economic scenarios, we keep the Federal Reserve Board scenarios loaded. You can also do moving averages, last point, linear trend extrapolation on the environment, that sort of thing. Or you can download an Excel template and fill in your own. And this template just has a set of columns, one for each variable in each state. And if you're in a few states, you can fill those in, or you can copy them in from your favorite scenario source. For origination scenarios, obviously I can do some predefined scenarios here, but you can also download an Excel template and fill it in the way you like. You can also change the segmentation in that template, just like I showed you on the home page, where you could change segmentation. This will let you say, I want to fill in my originations plan by state and source for auto loans. For a card, I just want to do it by FICO band, however you want. And that template will actually go back to your history and re-aggregate the history by the dimensions you've chosen so that you can extrapolate from your recent past. You don't have to look that up and provide it to us or anything like that. The combination of an economic scenario and an origination scenario is what we call collectively a scenario. So you can give that a name, any name you like. It could be Joe's severe scenario. And if I add that to the list, then it will appear as one of my options. Now, you can have many past scenarios that I can reactivate anytime I like. I can have as many as I want. Most of our clients run 2, 3, or 4 scenarios at a time. You notice that one of them has a star next to it. That star means that that's the reference scenario. That's the one that we're going to archive at the end of the month so that in the future you can compare back to it. And when we look at the CECL tab, you'll see one use for that comparison. So we think that's a very valuable thing. So by default, we just pick the first one you create as your reference. I recommend that you think about that and select it appropriately. The forecast range here is anything you want. In fact, it can even be in the past. If you want to run the whole software in a backtest mode and see how things would have looked, you can set this back to previous years. Going forward, it can be as far in the future as you want. Now, for CECL purposes, you do not have to change this. In fact, it's fair to think about this product as a suite of products. We have a forecasting and stress testing tool, which is what this forecast horizon applies to. And that allows you to have a new originations plan to project what your current portfolio will do along with new loans. The CECL tab, we have to follow the CECL rules. And so for term loans, it's through the full term of the loan. For lines of credit, you've got payment allocation rules, which can be quite complex. If you have loans that are past the end of their original term for various reasons, then we have to have logic for how to deal with that. So there are a lot of things that go into CECL. That's why we ignore this. For CECL, we use the CECL rules. For the margin tab, that's a new loan profitability estimate. You give pricing, you choose an economic scenario, we tell you what the outcome can be. And based on that, we're going to run the full life of the loan again. So again, the term only matters for the forecast tab. So you don't have to set it far into the future for CECL or for margin or anything like that. If your typical operation plan is to look forward a couple of years, then set it to 2 years or 3 years, whatever you like. If I hit forecast, this will take a few minutes to run because it's a monthly loan level cash flow model. There's a lot going on there, which is what we want in order to support all these different purposes, but it takes a little time to run. So I'm going to jump ahead using the forecast I've already got. I'll show you the data tab next. This is just a way to browse your historic information. I will show you more about these portfolio graphs when I go to the Forecast tab. Again, change dimensions. When you look at the Scoring tab, it's called Scoring Data because this is the information we use at the account level to look at how we're going to predict your accounts. And for example, if I come down here and said LTV, and let's look at just auto since that's where it applies. If I hit apply, I'll make a new graph. Now it's going back to that loan level data, re-aggregating it according to my choice, which is why it takes a second there. And now you can see over time, what volume do I have in different LTV bands? And this big orange band up here is not available. LTV wasn't captured in their system prior to 2010. Over time, it was replaced, but never completely. There's been 9 years that have elapsed. You would think that all loans, we know what the loan to value is, but maybe the data was in error. Maybe it wasn't recorded properly. There are various things that can happen, or maybe it wasn't captured. So NA is a category for us. We will model the risk of NA accounts in any one of our variables, but it's good to know how much is going to be in there versus how many accounts we actually know what the loan to value is. So these are all the variables that are currently in this auto score, and you could browse through and see what things look like. I should also note, you'll see download report buttons on every tab. We have summary reports where instead of asking you to go through and click on every combination to see every possible outcome, we will generate a report which summarizes this for you. And in fact, we have a good data quality report. I'll flip over to and show you a summary of that. This is our data quality report. And what it does is go through and, as I said, it summarizes the quality of the data being loaded into the system. And if we look down here, we have this nice little star rating. This is where we look at the length of history, the volume of history loaded, the completeness of variables being provided. Now, for this example, you'll see they don't have a lot of length. They've been capturing data a little over a year. They have very few charge-offs. And so their composite score based on that is kind of low. Now, we can augment their analysis with our shared data pool, and that boosts the star ratings. So this is a case where this client really needs the benefit of the shared pool because on their own, they don't have enough defaults to make a model. But we have a shared pool, which is collected. It's an opt-in thing. If you want shared pool models, you put your data into the shared pool. Nobody sees your data. They would only benefit from certain model components. Specifically from the shared pool, we look at the score odds calibration for things like FICO and LTV and so forth. We also look at economic sensitivities. We're leveraging part of that shared pool is an extract from FDIC and NCUA. So by state and product, we know the long-term history through a couple of economic cycles so that we can build models on that. We also have access to the Fannie Mae Freddie Mac data. So our real estate model is based on about $2.5 trillion in loans. So that's a pretty robust model, as you can imagine. So beyond these star ratings, we get down to specific improvements, certain factors that are missing for certain products. So going through product by product, what's the best way to improve the quality of this data set in terms of modeling? And it'll go through and give you a list. It also goes through and summarizes the data that we've been loading, and you can see this is how many summary graphs. Basically, we want to capture everything, and this is just a big library of outputs. So the total document here runs on 400 pages, but you could say, I want to see how many TDRs I've got in my CRE segment, and jump down here, and you can see they don't have any. Whereas if I look down a little bit, other categories, it's more interesting. So this document is meant as a reference when you're offline. So you don't have to have the software to see everything all the time. At the same time we generate this document, we would also generate a loan-level exception report. So for each account, you'll know. It's not just that you have a problem where 90% of the accounts are missing LTV. We'll actually tell you which ones they are. So that is our data quality report. We have other reports that I'll come back and show you, and we also have, you can see that this is really a report writer that we've got where we can have a template with text and spots for tables and graphs and so forth. So we can set up any kind of custom template that you might like. Another part of the historic data that we keep loaded is the economic history. This is where we automatically go out to the Federal Reserve Economic Data Repository called FRED. We refresh this data regularly from FRED. We capture the variables that we need. Obviously, FRED is massive. We don't need every variable they've got. Wouldn't even try. But we do capture the ones that are related to the Federal Reserve Board, CCAR, DFAST stress testing scenarios. Plus, we have to add a few other things related to consumer debt burden is on here because we find that to be predictive of some things that are going on today. You will see automatically checked the main states you're in, but you can browse any other state you feel like. Right now I'm showing unemployment. You can see some different scenarios for it. But if I scroll down, you can, let's look at house prices. I can apply different transformations if I want to experiment with the data. So year-over-year change, 12-month window. Let's see what house prices look like in those markets. Here you can see Washington State in red, and this is based on actual data. House prices were rising dramatically, 10% year over year, but that has started to come down, and the base and the severe scenario both have that rate of growth in house prices to be dropping. Whereas Alaska, house prices had been low and now are projected to recover a bit. The issue in Alaska was that with the oil price collapse back in 2015, they've been through a prolonged recession. That was actually visible back in the unemployment rate variable. This is relevant for when I show some other things. So here's the Alaskan unemployment graph, and you can see they stopped improving in 2015 and that started to deteriorate, but now it's improving again. Now, improving unemployment rate in Alaska, that's partly because of people who leave the state when they can't get a job. So this is not always the best variable. All right, so to continue walking through, the next tab to show you is the analysis tab. And we'll look at some of the model outputs here. Now again, it's not a model building tool. You don't have to spend time tuning or refining models. This is simply to view them. At any point you can come in and say, I want to see what all the model coefficients are. Absolutely every coefficient in the system is displayed, and all of the statistics behind the modeling as well. So you can see anything you like. The model that I'm showing here is the multi-horizon survival model, and that's just one of the models we have in our library. We did a book called Living with CECL Mortgage Modeling Alternatives where we compared a number of models, not even all the models we have, but the ones we could apply to that data. And in those studies, the best loan-level model was this multi-horizon survival model. It starts with a vintage analysis. So this first tab, decomposition, is really vintage modeling. And so as vintage modeling, you begin with a life cycle. So right now I'm looking at the 4-year Alaskan auto segment, and you can see for this segment, the peak loss risk is about month 13, and then things improve after that. So this is useful information. Of course, it's critical for portfolio forecasting and CECL forecasting, and for margin calculations. It's very important to know when the losses are likely to come, to know how much revenue you'll make before that peak, how many accounts will be around after that peak to continue making interest payments. So this is loss timing is a critical aspect of revenue. The graph here is the vintage credit quality graph. Now this looks very noisy, but this is not noise. This is an actual measure of the credit quality that was originated each month. It's like a seismograph trace. We use FICO and LTV and things like that in the modeling, but that's never the whole story, because at certain points in the economic cycle, such as today, I'm sitting here in September 2019, and if I look back the previous 7 years, that takes me back to 2012. This whole period is recovery. So if I look at the data at the credit bureaus, consumers look as good as they are ever going to look because unemployment has been very low. Consumers are paying their bills as well as they ever will. So I can have someone who may have had delinquency and utilization problems and things that would cause their FICO score to be poor in the last recession. That's all gone now from the bureau. All I see is good time. So you can look at trends of consumer behavior, and the irony is you might say, well, this guy's FICO score is trending better. That's great. But if I book a loan today and then we have a recession, I can't see the fact that the last recession he had problem and he may have trouble again next time. So FICO scores are actually a very lagging indicator of the credit quality of the consumer. And in fact, what we tend to find is that the best FICO scores happen right before the recession. And the peak in losses, of course, come during the recession and shortly thereafter. And so there's this odd thing that you get the worst performance from the best FICO scores. After the recession, when FICO scores are bad, you're going to get better than expected performance. So this seismograph trace measuring shocks to credit quality is capturing these effects. It's capturing the effect that there are residual impacts that your FICO and LTV won't see. And they can be dramatic because the zero line here is the life cycle. It's if I have an account or a vintage that has a zero credit quality measure, it means it's just going to be right on top of the life cycle. But if it's positive, it means it's more loss risk than what the life cycle says. If it's negative, it's less loss risk. Now the scale is log odds of charge-off, and so we're measuring change in log odds of charge-off. Now FICO score is also modeled as log odds of charge-off. This may sound like a technical statistical term, but any credit score is originally a measure of the log odds of default or charge-off. And then to turn it into a FICO score, they just change the scale. So we're keeping things in the native units here so that these graphs can be added together. We want to show the auditor or the validator exactly how the model works so we avoid unnecessary or arbitrary rescaling. Now, if I look on this graph, you'll see the last few years were quite dynamic for this portfolio. They went through a period of worse than average bookings, then a period of better than average, then worse than average again. These are specific policy changes. Again, this is not noise, and we measure this pretty early. Just after a few months, we'll start to see that the credit quality is not what was expected. So this is early warning information for the portfolio managers. That's one of the best uses of this analysis tab, is to understand early warning as well as just understanding how the models work. So the vintage graph was about credit quality. The environment graph is about what's happening in the economic environment. Now you can see here there's a big spike in this portfolio. That's a specific policy action that was taken based on a request from the auditors. Basically, too many accounts that were severely delinquent, so they had to do a catch-up. And so our analysis would capture that. It would see that spike due to policy. It will see spikes due to things like a hurricane that rolls through and causes a spike in delinquency or default. But then you've also got the long run trends that are really more economically driven. And this long rise here, again, higher means more loss. The zero line is again the life cycle. So it's saying that in 2017 and 2018, losses were higher than average. by a significant amount, and this is because of the recession that Alaska's been going through. You can see in the last 6 months that was starting to come down as the economy improves. The last graph here is really where this term multi-horizon comes from. That what we have done in creating this model is we've taken vintage models, and I don't think it's an exaggeration to say we are some of the leading experts on vintage models. We invented them for retail lending back in 1999, and we've been using advanced vintage modeling methods ever since. In the last recession in 2006, we had a number of clients running our vintage models, and the models were very effective. In 2006, they told several of our clients that they were going to have a significant increase in losses just in the next 2 years because of life cycle effects, the credit quality they'd been booking, things like that. Now, as useful as those were, and we were told by some clients that those 2, 3-year forecasts were within 10% accuracy, even though, of course, we couldn't predict the economy. But still, it doesn't tell you who. And one of the biggest problems with an aggregate model is that it may be right, but it doesn't tell you what to do about it. To get actionable information, you really have to be able to drill down to which accounts. Where is the problem? And so to get that, what we've done is to merge our vintage modeling with behavior scoring. Now, it's easy to say, but it's hard to do. It took us some years to figure out the best way to do this, and we're not the only ones who have been researching this, but we do have a very robust solution at this point. And so part of the key to doing that is that when we have coefficients that estimate how important delinquency is, for example, we have to consider how far in the future we're forecasting. So this graph is showing the zero line here, again, is the life cycle. How much more or less risk do we have for an individual account based on what delinquency state they're in? So the lines here are the different delinquency buckets. So current, not delinquent, is the black line, then 1 month delinquent, 2 month, 3 month, etc. And for this client, charge-off is happening at month 6. So this top line up here, a 5-month delinquent account today has very high risk of charge-off next month. This is the same scale I had before. And you remember, for environment, the peak of the recession for Alaska was about a level of 1. 1 on a log odds scale is about a factor of 2. This is coming up to 7. So it means that if you're 5 months delinquent today, the probability of charging off next month is in the 90% range. But these graphs are conditional. As I look further in the future, it's asking, if I look at month 12, what's the risk of charging off for that same 5-month delinquent account? And it's basically back to 0. Because if somebody was 5 months delinquent today and didn't charge off next month, they must have cured. The accounts that we see that survive in the long term, they must have been re-aged or some other programs, or they were able to refinance their home or something, that they got money and cured, so that once you get past that peak risk period, they're actually an average risk account. Each delinquency bucket has a different behavior. So ironically, the 1-month delinquent account, the red line, it has peak delinquency risk in month 6. But after that point, it actually stays kind of high, because my 1-month delinquent accounts, they don't have to do much to cure, and they may not really be cured. They may be sloppy payers. They may have a persistent risk. So you actually get an inversion here. The more delinquent they are, the lower the risk in the long run future. So this structure captures the detailed behavior of delinquency, and what it's really capturing is the decay of information with time. Honestly, I don't know any other models that do this. So this is a particularly valuable approach for being able to generate cash flows. With this kind of model, we can accurately predict the expected loss, the expected payoff, because we always model both the attrition rate and the charge-off rate, and of course the balances that go with those things. So that means that every month we're measuring expected payoff and expected charge-off all the way through the end of the loan. So that gives us cash flows from which we can get revenue, we can measure CECL, all of those things. So that's a little bit about how that part of the model works, but you can also step into the economic modeling. We take that environment function I showed you, correlate it to economic factors. So right now it's showing me Alaska auto. You can see there's seasonality factors in here, some regime shift variables from where they had policy changes. And then down here we've got employment, changes in employment, and changes in house prices. These are all of the model estimation coefficients. Again, you can see all the statistics if you want, or if you're like me, you can look at a picture. And the picture is going to show how well the model fit the historic data. Here is the black line is the same history I showed before. The blue line is our fit to that. There are some periods of divergence which are actually related to policy changes, which are not going to be captured in the economic model. And then you see what the two scenarios would look like for this model based on the severe and base scenarios. For scoring, you can actually come in here and look at every scoring coefficient, not just delinquency, but how important is deposit balance, how important is origination score, LTV, etc. And of course the difference between direct and indirect, those sorts of things. So you have access to all of these coefficients. And again, there's a download report button. This will save for you a modeling report. Basically, it has an introduction to how the model works, and then it's got all of the coefficients that go with it. So it's essentially a self-documenting model. The forecast tab is where it gets interesting. This is where you can actually see the output of the model. Let's come down here and look at something like charge-off, hit apply, and you're going to see two different alternatives for base and severe scenarios. And if I zoom in a little bit, you can see that they had their peak in losses back in 2017, early 2018. They've been recovering, and here are a couple of alternatives on what could happen as far as continued improvement. You can see some seasonality in here and the economic overlay. Now, this client started using our software way back in 2015, and the software was predicting increased losses during that time. That prediction was not just a forecast relative to the economy, but it was also related to the credit quality that they had originated. And so we were seeing by vintage, there were different risk levels for different pools. So I can look at that. I can come down and say, let's not aggregate all of my vintages. And of course, I could look monthly if I want to see in detail, but let's just look at some summaries by annual vintage. This is going to give me a graph where each line is a different annual vintage, and you'll see the history and the different forecasts. So here I've got my 2015, 16, 17, 18, actually 16, 17, 18, 19 vintages. And you can see the 2016 vintage peaked early and high. That's a large volume of risky accounts. The next vintage peaked a lot lower, and under those different alternatives, you can see what's happening there. Even the base scenario is not a great economic scenario. The 2019 vintage is coming in a lot lower risk, and so it's rising more slowly and peaking lower. Now you can also look at that, align those by age of the accounts, and this is just a nice visual to see how the early performance of the different vintages compares. So if I looked at this, I could say, well, you can see the difference between the 2016, 17, and 18 vintages. The 2016 rose much faster than the other vintages did. Of course, I can look at a charge-off rate or any other rate in the system. We've even got adjustments with loan participation or without. And any of these outputs, again, you can look at the history So I can see this by the different forecasts for the annual vintages, summarized any way you like. Now, I'm going to take this same perspective and jump ahead to CECL. What CECL is going to do is to run these forecasts through the full life of the loan and then add them back up. So as I come back to my CECL answer, same portfolio, same forecast model, but now I'm looking at the lifetime totals. And in this case, I'm using it discounted. It can be discounted or not, as you like. Again, everything is scenario driven. So if you want to see CECL with a severe scenario, you can do that. In fact, for the largest institutions, they are probably going to do a weighted average of different scenarios. And our IFRS 9 clients do a weighted average of different scenarios. So you can do that as well. One of our most interesting features is this comparison chart. It's a waterfall chart where you can pick a prior period. This is where it's so valuable to save previous forecasts. And then you can say, I want to compare to what I had, in this case, 6 months ago. So here's the previous CECL value 6 months ago. We have an increase in loss reserve because of portfolio aging, where accounts are moving toward the peak of their loss timing function. We've got new bookings. We've got changes in credit quality. All of these were additive pieces until we get to the economic scenario. And you saw in the last 6 months, the economy was improving in Alaska. So the new economic scenario is to assume an improvement instead of a deterioration. That assumption releases loss reserves. So the economic scenario is important under CECL. And in fact, in this case, accidentally, these things cancel out. And you can see that the new forecast is almost identical to what it was 6 months ago, but with offsetting pieces. So the story is much more interesting than to say no change in CECL. It's there would have been a change, except that the improving economy offset increased losses from some of these other pieces. Of course, you can look at this by different product types. Right now, we're looking at the credit card. Okay. Now, we have a tab here called validation. At any point in time, you can run a validation test. I told you that you can run the whole software suite in backtest mode, but that's kind of a big activity. The entire system will be running in backtest. Locally, I can just do a small validation test. I can say, show me what my forecast would look like if I start from a certain point, run for a certain period of time. Now, again, I always like the visuals, so let's look at a plot of this. And this is going to show me month by month the actuals versus forecast. And in this case, I have a choice. Do I want to include new originations? No, I didn't include new originations. So the black line here for the portfolio is adjusted for no new originations from my forecast start date. And you can see it's pretty close. That's a pretty good forecast. Now there is some divergence here. When they diverge, that's a good conversation to have with management. In this case, this is not actually a forecast error, but that's one of those policy changes that I mentioned earlier. So this kind of validation test gives you an opportunity to see if anything is happening that needs to be discussed. We also have ROC curves and economic sensitivity tests, those sorts of things. So you can run and see these things at any time, download reports, and so you can get a self-made validation report on the fly anytime you like. Now, when I mentioned CECL, I didn't mention the CECL report. Let me show you what we generate there, because again, you won't necessarily want to click through every different graph and combination, so we package this all in a report. Okay, so this is one of the reports that can be automatically generated and saved from the software. And one thing you'll notice, I mentioned that we have a library of models. In the software, that's where you're interacting with the primary model that you've chosen. But you can choose to have us test a range of models in our library. In fact, there are other model types. If you have rated securities, you'll see a model column here for our loan migration, our rating migration model. based on Moody's and S&P ratings. Here's our advanced PD. In this case, the roll rate column is all NA for this client because they didn't report delinquency. If we don't have, or at least not enough, so if we don't have enough delinquency history, we can't create a roll rate model. Then we've got a vintage model and a time series model, and you can do this comparison, and we can turn these off. This is just a one-time test where the client wanted to see everything that applied to their data. There's no FICO migration model here at all because they're not reporting that either. We have the roll rate turned on in hopes that they'll have enough data for that to be populated. But you might choose to have only two models shown here so that you've got a primary and a secondary. Again, totally up to you. Then we've got the outputs of each model, and you'll see the same kind of outputs replicated for each model. If I go to our advanced PD model, there's a brief description here of how that model works with some reference material, and then it gets into what are the outputs by the different product categories, the CECL estimates, net of charge-offs, discounted, and what's the history. Sometimes measuring the history is difficult. If there's been one loss in the last 3 years, that's not a loss rate. So we can go out and look at FDIC if you're a bank and see what your loss rate has been there, and if it still shows $100,000 1 year out of 3, we may have to look more statewide to figure out what an appropriate loss rate is for that product, because unfortunately 0 is not an acceptable answer for CECL. Then we get into more of the details. So summary graphs for each product. What are my loss projections by vintage? Of course, here we've got that in a table form, looking at all the vintage diagnostics. And there's lots of outputs here broken down by segment. In fact, let me scroll forward a little bit. Then we've got comparisons across different product types. We have the stress testing outputs in here where applicable, where we've got the scenarios chosen. So there's some different scenarios here. And then we get down to the other model type. And at the very end is where we're going to have the graphs of the economic scenarios and those waterfall charts, all those sorts of things. I'm going to switch back to the software then and can finish out the demo. As I mentioned, in this suite, the last thing to show you is the margin tab. Here we've got the ability, again, download an Excel template, but this time what you're going to fill in is a rate sheet. I don't believe that it's possible to optimize pricing. There are plenty of price optimization tools, and that tool might tell you that you need to raise prices so much because of the possibility of recession and the risks in the market and all that. But if you raise your price, you get no volume. So telling you what price to set things at often doesn't matter when you look at the market. So instead we would say, tell us what the market price is. If you think you can make some adjustments, quarter point here or there, fine. You can experiment with that. What we're going to do is the cash flow simulation based on your price sheet, your expenses, so that we can look at lifetime yield, annualized yield, those sorts of measures. And you can scan then across your segments. You choose the dimensions for segments. In this case, it's state, new and used, direct, indirect. See what it looks like under different scenarios, and then ask which segments would be most profitable for you to move into. So the idea is to use this to guide your volume. So if you can't change pricing, but you're worried about a recession, you pick severe recession and you look across this and say, well, some of these don't look good anymore. Now, in this case, they're actually not seeing those negatives, but I can tell you sometimes there'll be negatives in here where depending, this severe scenario is not very severe, to be honest. But if I have a severe enough scenario, a severe enough recession, I may want to get away from cells on this matrix that could be negative, and focus my volume in areas which are more resilient to what a recession could look like. Once you've come past a recession, you will find invariably people are overpriced. And what that means is that you'll have an opportunity where you know the real risk for subprime, for example, is less than what the market thinks because the recession is behind us, and you may not want to drop your price much, only enough to capture the kind of volume that you want. So that's the way this tool works. Now, this is a suite of these three tools: forecasting, CECL, and margin. We actually offer an add-on to the suite, which is the investment module, where you can do valuations on loan participations, look at valuing participations that you may have purchased. So if I switch over quickly to another demo, what you see here is an example of an investment portfolio. This is an investment screen where I'm now looking at, by each segment, and you can control the segments, what is my lifetime internal rate of return, GCL, yield, what do my cumulative loss rates and paid off rate curves look like. And you know, these are all aggregated across those segments, but you can disaggregate to see how this looks by any segment you want to drill into. So these yield analytics are there for your existing portfolio, for things you want to sell, or for things you're considering buying. We have an API that can be accessed where you could send a file of a loan level file performance, and we would analyze that and send you back a account level projected yield and IRR, so you could decide if you want to buy that pool or kick out certain accounts. So this is an add-on module, and really this is our business plan. That we didn't build this for CECL. We had already built the forecasting and stress testing tool, the validation tab, the margin tab, and then CECL was announced. And when we looked at what we had, it took us only a week to roll out the CECL tab because we already had a highly accurate loan level monthly cash flow model. You couldn't do any better for CECL than that. So it was a simple matter of turning that on. Our business plan is to keep adding these tools. So the model that you invest in, maybe for CECL, maybe for pricing, wherever it is, you'll be able to use that same model across a range of things. And we have clients experimenting now with using it for upsell, with using it in collections. And we'll be adding other capabilities as well.
As part of our validation, we know that auditors need additional detail into how the calculations work. So another thing we provide, we call amusingly the blue sheets, which is an example where you can request the detailed calculation level outputs for an individual account or a group of accounts. So each spreadsheet is a single account. And what you can see here is a tab with the performance history for this account, including all the data we've got in the system as far as behavioral information and origination information. We've got some overall parameterization, product type, vintage, term, some of the parameters related to how we handle mean reversion, all that stuff. And then we have the calculations. And so this is showing month by month all the factors that go into the model. And in this case, it's the advanced PD model, the multi-horizon survival model. I specifically picked an account that was delinquent. It's not delinquent enough to charge off immediately. In fact, given its state of delinquency, there's a low risk of charging off the first 2 months of the forecast, but then you can see increasing risk with an actual peak 4 months from now and then declining after this. So that's capturing those details we saw related to delinquency and the decay rate of the information. So these are the final outputs. You'll notice there are equations here. So this has all of the math on how things are combined to get to the forecast. And if I scroll to the right, you're going to see the inputs. So for the PD model, it's a combination of life cycle environment scoring. So The lifecycle function is a lookup table from the vintage modeling. The environment has the factors, real DPI, unemployment, etc., go into the specific model and how they get added together, and the mean reversion calculation. Then we've got the scoring components in here. So LTV, debt to income, original balance, and delinquency bucket, because this is a account that's currently delinquent. And then we go further to the right and you get all the same thing for the attrition model, early payoff. So again, the combination of life cycle, environment, scoring, and all of those calculations. So our goal is to give you every step in the calculation for the forecasts. This doesn't show you where the coefficient estimates come from. That's the detailed validation documentation. But for an auditor, we've had a great response as far as showing them this and saying that they can trace the input data. They can pull this account and confirm that it ties out exactly to the input data. They can see all the parameters used in the calculation, and then they can follow step by step, month by month, how we predict the losses. And then if you add this column up, that sum is going to be the CECL estimate that we report in our system. And if you divide that by the current outstanding balance, you're going to get the loss rate, the reserve rate that's expected. So we think that's a valuable part of the validation suite overall.
So thanks for your time today. That's our demo. Please send any questions you might have. We're happy to help.